Welcome everybody to another video lesson. Today we're looking at arithmetic sequences. So we're looking at a specific type of sequence. We'll be able to find the nth term and arithmetic means of our arithmetic sequences after this video. So let's get into our concepts. First off, what is an arithmetic sequence? Well, it's just a sequence with a common difference between consecutive terms. And we denote that common difference with a lowercase d. So an example here, I've got 3, 7, 11, 15, 19, 23, and so on. See here, we are adding 4. We're adding 4 in between each term. So that means our common difference, d, is equal to positive 4. Now we have a formula for the nth term, finding the nth term of an arithmetic sequence. That's going to be a sub n equals a sub 1 plus n minus 1 times d. And we can verify this by just a quick example. If I'm given that a sub 1 equals 2 and our common difference is equal to 3, then I would know that I would just add 3 each time and I would come up with this sequence of 2, 5, 8, 11, 14, 17, and so on. Now a sub 1 is just 2, but a sub 2, if we use this formula here, would be a sub 1, which is 2, plus n in this case is 2 minus 1 times our common difference of 3, and we would get that that is equal to 5, which is what we have here on our list, so that's good. Now, if I look at a sub 3, that again is going to be a sub 1, which is 2. Now my n is 3 minus 1 times our common difference of 3. That's going to be 8, which checks out. And same thing with 4, and that's going to be 11. And with 5, that's 14. So this formula checks out. So now let's look at first and second differences. So our first difference is found by subtracting each term from its previous term, from its successive term. So we would think of that really as our common difference for arithmetic sequences. So here we can see we have a common difference of positive 7, so that would be our first difference there. Now when we get into different other types of sequences, we are going to see that they might not have a common difference for their first differences. However, we can take a look at their second differences, and that might tell us something about that sequence. And the second difference is found by just subtracting our consecutive first differences. This is my sequence, at the top. So this is 5, 14, 27, 44, and so on. This is my series. My first differences we can see are 9, 13, 17, 21. So our first differences are not the same. However, when I subtract these from each other, I get a second difference of positive 4. Second difference of positive 4. So that tells me that I can actually model this with a quadratic function. Okay, so that's what second differences can tell us. If those second differences are all the same, then our sequence can be modeled with a quadratic function, which we're going to do with our last example today. Speaking of examples, let's get right into determining the common difference and finding the next 4 terms for each of these arithmetic sequences. So let's take a look at the first one. First thing we want to do is find out what our common difference is. So to do that, I'm going to take my second term and subtract the first term. And when I do that, I'll find that we have a positive 31 for our common difference. Now, don't just do 1. Go ahead and do every term that it gives you, every pair, just to go ahead and make sure that these are the same, in fact. And when we subtract negative 67 and minus negative 98, we get a positive 31 again. So we are, in fact, adding 31 to each term. So my common difference is positive 31. That is the first part of this problem. Now we would need to just find the next 4 terms of this arithmetic sequence. So we're just going to start off with negative 67. We'll add 31, get negative 36. From there, we'll add 31 again. We get negative 5. From there, we add 31, we get 26. And then we add 31 again, and we get 57. So these 4 numbers here are the next 4 terms of this sequence. All right, so you guys pause the video and do the same thing with this sequence here. 244, 187, and 130. Alrighty, hopefully you got a common difference of negative 57, and these are your next 4 terms. All right, let's take a look at explicit and recursive formulas. So we're going to find both an explicit and recursive formula for the nth term of this sequence here. So first thing we want to do is find our common difference, and we do that again by just subtracting the second term, or subtracting the first term from the second term. So 23 minus 35 is going to be negative 12, and then 11 minus 23 is negative 12 again. So my common difference is negative 12. Now we want to use the nth term formula for our arithmetic sequences, and that's going to get us the explicit formula, okay, which we have here. So I just plug in a sub n, our 35 initial value, that's the first term here, is equal to, we found our difference to be negative 12, so that's negative 12, n minus 1. Now I'm just going to distribute this negative 12 and simplify this a little bit. So I get 35 minus 12n plus 12. We'll simplify that to have a sub n is equal to negative 12n plus 47. Okay, so this would be the explicit formula for this arithmetic sequence. Now we need to find the recursive. So to do that, we just need to do it in 2 steps. We need to state the first term, and then we're going to write a sub n as the sum of the previous term and d. Sum of the previous term and d. So all we need to do is we say a sub 1 equals what, and then we have a sub n equals a sub n minus 1 plus d. That's all we need to do. So a sub 1 is 35 in this case, and a sub n would equal a sub n minus 1 minus 12. Okay, so that's how we would set that up as a recursive formula. All right, our third example, finding the nth term. Let's find the 38th term of the arithmetic sequence, negative 29, negative 2, 25. So we're going to use our formula here. We know that a1 is negative 29. We know that n is going to be 38 because it's asking us for the 38th term. Now we just need to find our d, our common difference, which we can do that, and we would find that to be 27. So d is 27. We would just plug all these values in, right? A sub 38 is equal to negative 29 plus 38 minus 1, all quantity times 27. So that's going to be, once we start simplifying this, a sub 38 would be 970. All right, fourth example, again, we're going to practice finding m terms, but this time we are practicing finding d. We're going to find our common difference now. When we are given a sub 1 equals 75 and a sub 38 equals 56.5. So this is kind of the situation that we have. We've got our first term of 75, we've got a bunch of terms here, and then we have 56.5 here as our a sub 38. We need to find the common difference. We can do that again using this formula. All we're going to do is plug in a sub 38 equals a sub 1 plus 38 minus 1 times d, and we have values for both a sub 1, a sub 38, and n, right? We know n is going to be 38 because that's what this value is here. So when we plug that in, and we can just start solving this for d, divide by 37 on each side, and we find that d is equal to negative 1/2. Alrighty, fifth example, arithmetic means. All an arithmetic mean is, those are just terms between two non-consecutive terms of an arithmetic sequence. So if I said, what are the arithmetic means between 4 and 12? Well, that would be these three terms here, 6, 8, and 10. So that's arithmetic means. So if we're asked to write a sequence that has 6 arithmetic means between 12.4 and negative 24.7, what would that look like? Well, we would have our original term here, 12.4, our initial term, and our last term here of negative 24.7, and we have 6 terms in between them, right? 1, 2, 3, 4, 5, 6. So I got our first term. This would actually be a sub 8, right? Because I've got 6 plus this one. This would be a sub 8. So now we can use our formula, our handy-dandy formula again. We got to find out what d is, right? So we have values here. If I have a sub 8 is equal to a sub 1 plus 8 minus 1. That's what we have here. And then we're just going to solve for d and find out that d is equal to negative 5.3. So now starting at 12.4, I just subtract 5.3 and I get 7.1. And then again, moving on to the next term, I would subtract 5.3, I get 1.8. Subtract 5.3, I get negative 3.5. Subtract 5.8 again, I get negative 8.8. Subtract 5.3 again, and I end with this negative 19.4. Now, one easy way to check if you made any errors is just to subtract negative 5.3 again, and you should end up at this a sub 8 term. So if I were to subtract 5.3 from here and it didn't equal negative 24.7, I would know I did something wrong. All right, last example, looking at second differences. Sorry, I know we have a lot of examples in this one, but we're going to look at second differences, find a quadratic model for this sequence. So if you take a look at this quickly, you can tell that I don't have the same first difference, right? First I add 10, then 12, then 14. So my second differences hopefully are the same, but our nth term we are actually going to represent almost like a function notation. Okay, this is very similar to if I had put f of x equals ax squared plus bx plus c, right? You guys have seen that many times for the quadratic formula. However, now I have a sub n, so this is my term that we end up with, is going to be equal to an squared plus bn plus c. So it's very similar to, say, function notation that you guys have seen. Now we have three unknowns, a, b, and c in this case. So we need to set up three equations, and I'm going to do that using a sub 1, a sub 2, and a sub 3. So when I do that, I would say negative 14, that's a sub 1, is equal to a 1 squared, because my n value is 1 here, plus b1 plus c. And then I would do that again for a sub 2. So negative 8 is equal to a 2 squared, since my n value is 2 there for a sub 2, plus 2b plus c, and then again for a sub 3. So now when I clean that up, I have this nice system of equations. And if you guys remember from our matrix unit, we could set this up as an augmented matrix or as a matrix equation, and we could solve this. So if you don't remember how to do that, go back and look at the matrix equation videos. And when you solve this, you'll find that a equals 1, b equals 3, and c equals negative 18. So my final model, my final quadratic model for this would be a sub n is equal to n squared plus 3n minus 18. This would be the quadratic model for this sequence up here. So that is it, guys. That was a little bit of a longer one, more examples, but good luck with your practice.